Welcome to this explainer. If you're like most people, you probably trust your senses, right? You absolutely trust that the floor beneath you is solid, that time ticks forward at a constant, reliable rhythm, and that the physical world behaves in, well, entirely predictable ways. But what if I told you that the solid, predictable world around us is actually hiding a massive, mind-bending secret? Today, we're pulling back the curtain on modern physics to reveal that almost everything you intuitively believe about the universe is fundamentally incomplete.
Okay, let's dive into this. Take a quick second and just look at your immediate surroundings. Look at the screen you're using right now. Feel the chair you're sitting in. It feels incredibly solid, doesn't it? It feels fixed, permanent, and undeniably real. But is it possible that the absolute reality you see and feel right this very second is merely an illusion? To really grasp the true nature of existence, we have to start questioning the very fabric of our everyday experience.
There is a stark, absolute contrast between human perception and scientific reality. On one hand, we have the world of classical physics, the everyday world of Isaac Newton. In this view, objects are solid chunks of matter, and time is like this invisible, perfectly steady metronome just ticking away in the background. But modern physics tells a completely different story. It tells us that those solid objects are actually mostly empty space, and that time itself isn't a steady ticking clock at all. It's actually a flexible, warpable dimension.
Section 1. The illusion of everyday life. To truly understand the universe, we kind of have to temporarily abandon what our own eyes are telling us.
Get a load of this number, 99.9999999%. That is the staggering amount of an atom that is entirely, completely empty space. All the matter in the universe is made of atoms, which means that chair you're sitting in, the screen you're looking at, and even your own body are almost entirely made of nothing. The only reason you don't fall right through your chair is because the tiny, minuscule fraction of actual matter in your atoms contains electromagnetic forces that fiercely repel the atoms in the chair. So playful as it sounds, you aren't actually touching anything right now. You're just hovering infinitesimally close to it, repelled by invisible force fields in a vast ocean of empty space.
So, what happens when we shift our focus out to the cosmos? Let's jump into Section 2, Bending Space and Time.
Before Einstein came along, we basically thought space was just an empty stage where things happened, and time was just a stopwatch recording when they happened. But Einstein merged them into what we call space-time. Space and time are not separate entities. They are deeply and fundamentally interwoven into a single, four-dimensional fabric. You literally cannot move through space without altering how you move through time. So, the crucial point here is how this fabric interacts with matter. For centuries, we thought of gravity as this invisible, magnetic-like tether pulling objects together. But Einstein showed us that gravity isn't a pull at all. It's a curve in the fabric of space-time. Imagine a bowling ball resting on a trampoline. The ball creates a deep dip in the fabric, right? Now, if you roll a marble nearby, it doesn't get pulled by the bowling ball, it just follows the downward curve of the trampoline's fabric. Massive objects like stars and planets literally bend the reality of space-time around them.
And because space and time are the exact same fabric, when space bends, time bends right along with it. This brings us to a massive, mind-blowing practical concept. Time is strictly relative. Because Earth's mass bends space-time, gravity is slightly stronger on the surface than it is out in orbit. Therefore, your clock down here on Earth literally ticks at a fundamentally different, slower rate than a clock on a fast-moving satellite up in space. We actually have to mathematically correct the clocks on GPS satellites. If we didn't account for this literal bending of time, the navigation systems on our phones would fail within minutes.
Now, to find the universe's strangest secrets, we have to zoom infinitely inward. Section 3. The Blurry Quantum World.
Down at the subatomic level, the solid certainty of the universe completely evaporates. It's replaced by mere mathematical probability. Take the core concept of superposition. In our everyday world, you flip a coin, it's either heads or tails. But in the quantum world, before you look at it, a subatomic particle exists as both heads and tails at the exact same time. It exists in all its possible states, spinning in this blurry cloud of simultaneously overlapping realities.
These bizarre quantum rules brilliantly illustrate just how totally alien the microscopic realm is from our own. Particles can literally be in two places at once. Absolute certainty? It doesn't exist down there. It is all governed by probability. But that third point is the absolute most shocking of all. The mere act of observation somehow changes the physical outcome.
To wrap our heads around these invisible quantum anomalies,
Physicists rely on famous thought experiments, like Schrödinger's cat. Imagine a cat in a sealed box with a completely randomized quantum-triggered mechanism that might release a poison. Because the trigger is a quantum particle in a state of superposition, the mathematics strictly dictate that until you open the box to check, the cat inside is essentially both alive and dead simultaneously. It's the act of looking, the actual act of measuring, that forces reality to pick a single state.
Which brings us to what is easily the most unsettling part of modern physics, Section 4, the observer effect. Let's walk through exactly how looking forces reality to make a choice. Step 1. When no one is looking, a subatomic particle doesn't behave like a solid object. It acts as a wave of pure probability rippling through space. Step 2. A scientist turns on a detector to measure it. Step 3. At that exact moment of observation, the wave function violently collapses. The hazy probability just vanishes, and the particle snaps into a single, definite physical location. Reality literally waits for us to observe it before deciding what to be.
Check out this profound quote from our source material. The universe's subatomic building blocks dissolve into a haze of probability when unobserved. I mean, take a second to let that really sink in. The very building blocks of your body, your room, and your whole world rely on a bizarre mathematical magic trick that we still barely comprehend. The sheer awe of the universe we live in is absolutely staggering.
Let's bring all these macro and micro shifts together in Section 5, redefining our reality. Why does all this matter, and what should you truly take away from this explainer?
Let's see how this builds into one cohesive picture of existence. On the everyday scale, classical physics gives us the illusion of a solid, predictable reality. But as we expand to the cosmic scale, relativity reveals a reality of warped space-time where gravity bends and time dilates. And then when we shrink down to the subatomic scale, quantum physics uncovers a blurry reality of probabilities, superpositions, and observer-dependent outcomes. Basically, our everyday experience is just a very narrow, very specific slice of a much wilder, much more complex universe.
So we've mapped out the emptiness of atoms, the actual bending of time, and the incredibly strange power of the observer. Physics has proven beyond a shadow of a doubt that the world you see is fundamentally a constructed illusion. Which leaves us with his final provocative thought. If our eyes, our hands, and our very senses are so convincingly lying to us about the nature of space, time, and solid matter, what else is out there, right in front of us, entirely unseen? Keep questioning, keep learning, and thank you so much for joining me on this explainer.